Alright, this is part 2 of the practice final, starting with 13. Jordan scored a 96 on his chemistry final. The mean score was an 84. Standard deviation was 10. We want to know what Jordan's z-score was. Alright, remember z-score, same thing as the t-score. Z is equal to the value from the data set minus the mean, and then divide that by the standard deviation. Alright, so in this particular case, if I take his value was a 96 and I subtract the mean, which was 84, and then I divide that standard deviation, which is 10, I get 1.2. Alright, now you got to make sure that you remember value goes first. We always subtract the mean from the value. Right? If you did it the other way around, if you took the mean first and then you subtracted the value, then you're going to get the opposite. Right? So make sure that you don't make that mistake. Okay? It's the value minus the mean divided by the standard deviation. So we get positive 1.2. Alright, another big mistake people make here is they don't put the parentheses in there. Alright, luckily it wasn't an option this time. Okay, but it very well could be if you screw it up. Okay, so just make sure you put it in parentheses, or if you don't put it in parentheses, do it in two parts. Oops, divided by 10, not 2. Alright, so our answer is 1.2. Alright, which of these is not an interpretation of the value represented by alpha? Alpha that we use for hypothesis tests, and we use it for, we also have been using it for regression here at the end. It's called the level of significance, so it 100% certainly is A, the level of significance. But this is asking which is it not, which is not an interpretation. It's also B. B is also an interpretation of alpha. The area of the rejection region, or the area of that we shade when we do a hypothesis test, is the probability we reject the claim given the claim is true. If we look at a picture, if I have alpha equal to 0.05, and let's just hypothetically say that I'm doing a left tilt test. Okay, so alpha 0.05 is somewhere down here. Okay, if I were to shade this, that means that this area down here below whatever that critical number is, like negative 1.645, that area down there has is 5% or 0.05 of the total area under the curve. Okay, now if this is a claim mean here, somebody makes this claim and we take a sample, and our sample mean occurs down here somewhere. Let's just say it's right here on the number line. Alright, so it occurred in our rejection region. We would reject the claim. We would reject whatever this claim mean was, because our sample is providing evidence that that's probably not true. What it's saying is, under the assumption that this is true, for me to get a sample this far away from that claim, there's only a 5% chance or less that I would end up in this region. So that's when we reject this. If our sample mean, or again if it were proportion, were to fall in this shaded region, or on the number line in that shaded region, then we reject this claim. Now, could we reject the claim when this is true? Yeah, we could. Alright, it's not likely. For us to get a sample mean that's down here, we would have had to have gotten the smallest values from the data set at random, and it could happen. We could possibly just randomly select a lot of short people if this was mean heights or something. But it's more than likely not going to happen. Right? And again, there's only a 5% chance that any sample mean would fall down here. So could it happen? Yes. But that's what another interpretation of alpha is. It's the probability we reject it when we shouldn't have, because our sample evidence showed us that we should have, but it was just a bad sample. It was just a sample that wasn't really representative of the population. So that's the other interpretation, the big interpretation of alpha, rejecting the null hypothesis given that it's true. Alright, so that leaves this is our one that's wrong. Okay, the probability of not rejecting when it's false is not what alpha gives us, but it does give us part B. Alright, determine the critical value t.1 with a sample size of 28. Alright, if it's a t critical value, because not everybody has that feature on their calculator, the only way that I showed you guys was to use the table. Alright, and you will have a table present for your final. But because some of the 83s don't have the feature that the 84 does to do this, then you need to use the table. So we need to have kind of a uniform way to do it. Alright, so on the table, it's table A3 in your book. This is critical t values. Alright, area in one tail, area in two tails. And the problem, when it's just 0.01 like that, it's just, or sorry, 0.1 like that below, it's just the area in one tail. Alright, so we need the sample size to get the degrees of freedom, and then we need the 0.1 in one tail. So area in one tail is 0.1. The degrees of freedom is one less than the sample size, so we need a 27 degree of freedom. So 27 in this last row would be 1.314. Okay, so 1.314 is our answer here. Alright, so you can use, if this were a z, we could use our calculator, but for t we got to use the table. Alright, a mean of 42.5 and a median of 47.5 were calculated from a data set. This data set may exhibit, alright, when the mean is less than the median, that means a tail is pulling the mean down to the left. So that means we have left skew when the mean is less than the median. More than likely we have left skew. Alright, determine the margin of error. We got a 95% confidence interval. There it is. We want to know the margin of error. Alright, remember, margin of error, very simple formula for margin of error. You just take your large number, you subtract your small number, and you divide that by 2. And that'll give you, take the large number minus the small number divided by 2, and that'll give you the margin of error. So for this particular problem, the large number is 52.95. We subtract the small number, 46.55, and then we divide that by 2, and we get 3.2. Alright, just like before, if you're going to do this all at once, you need those parentheses. Otherwise, it'll do the order of operations incorrectly. Alright, Dr. Ivana Nutterwan teaches stats course at Backwoods University. We want to determine the probability from this data set a student earned a B given they are male. Earned a B given they are male. Alright, so first thing we need to do is determine how many males there are. So there's 6 and 3 is 9, 11, 12, 13 males. And how many of those males earned a B? 6. So 6 out of 13 is our answer, which is H for some reason. Alright, 19. Suppose a simple random sample of size 36 is obtained from a population that has a mean of 65, standard deviation of 8. So describe the sampling distribution. Alright, remember, the mean of the sample means is the mean of the population. So all these have 65. But the standard deviation of the sample means is equal to the standard deviation from the population, which is in this case 8, divided by the square root of the sample size n. So in this case that would be 8 divided by the square root of 36. Square root of 36 is 6, so that's 8/6, which reduces to 4/3. So that's our answer. Alright, and then 20, the last one in the multiple choice. In a recent study of a new drug, 18% of users experience severe headaches. At Mercy Me Memorial, 10 patients have been prescribed the new drug. Describe using the binomial distribution, determine the probability. At most 3 will experience headaches. All right, remember, at most probabilities with binomial distribution equals the binomial CDF. All right, NPX. All right, so in this particular problem, we're going to say the distribution menu to get our binomial distribution, and we need the binomial CDF. All right, N, how many patients were there? There were 10. P, what's the probability a patient gets a headache? It's 0.18, since that's the empirical probability. And then how many? At most what? At most 3 will get a headache. And then we hit enter, and we get 0.9117 to 4 decimal places. So there's our answer. Alright, so there is the part 2 of the final exam practice. Next part's going to be the long answer stuff, or at least part 1 of the long answer.